about the one of the model, that is the small signal BJT model. So the BJT, the behavior of the BJTs can be analyzed using different types of models like hybrid pi model, RE model, T model, all these things. So this is the one of the method, one of the model, popular model used for analyzing the small signal behavior of the BJTs or FETs, that is bipolar junction transistor and the field effect transistor. Okay, so this hybrid pi model, it is a linearized two-port network. So as you can see in the figure, it is a two-port network approximation to the BJT using a small signal based emitter voltage VBE, as you can see in the figure, plus minus, that is the input we are providing VBE based emitter voltage, and the collector emitter voltage, okay, VCE, collector emitter voltage, as independent sources. So this VBE and VCE, it is a independent sources, whereas your base current and the collector current IB and IC will be considered as dependent variables. Okay, so in this hybrid pi model, what and all we are going to determine is, that is, we are going to concentrate upon is, one is regarding the transconductance, that is GM. We know GM is nothing but the slope of the curve, that is IC versus VBE. So the slope of the curve is known as the transconductance, and also we know it is a ratio of collector current to the thermal voltage IC by VT. And then we are going to determine the input resistance with respect to base terminal. See, when I say input, input is applied for the base as well as the emitter. So we have to see the input resistance both from the base point of view as well as from the emitter point of view. But in this figure, we have considered a resistance with respect to base terminal. So it is going to be represented by R pi, that we know. So the input resistance, it has been mentioned over here, R pi. So the whatever the voltage we are applying, it is VBE, and this is the base terminal, emitter and the collector. IB is the current flowing in the base terminal, IE is the current flowing in the emitter terminal, and IC is the current flowing in the collector terminal. And here at the output side, what we are going to get, it is GM, that is transconductance into the input applied. So this is something like gain factor, constant factor, IC divided by VT. VT is a constant, that is thermal voltage, it is 26 millivolt, and whatever the current we are going to get, so the inverse of VT and IC, which will give us the transconductance GM. Okay, so when I say voltage gain point of view, it is like input impedance, output voltage divided by the input voltage. Output voltage is VCE divided by VB, so that is nothing but your GM. GM is GM. Okay, so here it is mentioned current will be flowing like this. Okay, and then so this will be at the output side, it has been mentioned as GM into VB. So what is R by input resistance? Input resistance is nothing but beta divided by GM. Okay, so what is beta? IC by IB. IC by IB is nothing but beta. So so this will be, input resistance will be beta divided by GM. Okay, so the first, and we know your small signal model of BJT, which can be represented as a voltage controlled current source or current controlled current source. So when I represent it as a voltage controlled current source, what do you mean by voltage controlled current source? Your collector current, output current, it is going to be controlled by the input voltage applied VB. Okay, that is voltage controlled current source. Or else the one more name we can give for voltage controlled current source is transconductance amplifier. Means here we are going to get gain in terms of transconductance, GM. Okay, next is second figure. Whatever the second figure you are seeing here, this is acting as a current controlled current source. In a sense, here it is been differentiated as, see, inside this blue box here it is mentioned VB, means it is a controlling voltage, whereas here controlling quantity is base current, means in terms of current it is, and finally the current, output current, it is going to be controlled by the input current IB, and VB that is input voltage, it has been represented outside the box, whereas here inside the box. So this represents, that is to only get to know that this is current control current source and this is voltage control current source. Okay, so current control current source is also known as current amplifier because the gain we will get in terms of current only. Beta is equals to IC by IB. Both input and output it is in terms of current, but here output is in terms of current, input is in terms of voltage, so it is transconductance. IC by VBE. Current by voltage it is, so it is transconductance. Okay. So next is, as I told, we need to know GM, R pi, and one more factor is there actually, output resistance, but output resistance it is not been mentioned over here. If it is mentioned, we need to calculate that also. Okay, so the next slide, which will give us the information, that is whatever I had explained, the few points. So this picture, this particular hybrid pi model, it also yields the collector current, that is instantaneous collector current, as GM into VB. And you can notice here, like whatever the current and voltages it has been mentioned in the model, it is of the AC. It is of the signal because of the signal component VBE, input resistance, and then IE, small IB, small IC, GM into VB. So all in terms of small letters means it is AC component we have represented in the figure. So this particular figure which yields IC, collector current, as GM into VB, right? Transconductance into VB. See, IC is equals to GM into VBE. Next is IE. We can also calculate IE, amount of IE, emitter current, that is nothing but IC plus IB. See, what is IC? IC is nothing but GM into VB, that we got to know from this. And what is IB? IB is nothing but VBE by R pi. VBE by R pi. Or else R pi is equals to, we know R pi, input resistance with respect to base terminal, is nothing but VBE divided by IB. So IB can be written as VBE divided by R pi. Now take VBE by R pi as common. So what you are going to get inside the bracket, 1 plus GM into R pi. And then we are going to represent this, that is GM into R pi, as beta. How we will be getting this? That I had solved here. So inside the brackets, you will be getting GM into R pi. So we know GM is nothing but IC by VT, right? Collector current divided by VT into R pi. R pi is nothing but VT divided by IB. That is in terms of base current, it is VT divided by IB. So VT it will get cancelled. You will be getting IC by IB. So what is IC by IB? It is nothing but beta. Okay, so VB divided by R pi into 1 plus beta. Or else we can write this as, taking this 1 plus beta terms to the denominator, it will be like VB divided by R pi divided by 1 plus beta. So what is the relation between the input resistance with respect to emitter and with respect to base? We have already calculated. That is R pi, which is equals to RE times 1 plus beta. So R pi divided by 1 plus beta is nothing but RE. So IE can be written as VB divided by RE. Okay, VB divided by RE. So this is what we can conclude from this. We can calculate IC, we can calculate IE. Okay. So next is, this is with respect to the second figure, current controlled current source, that is this figure. See, in the exam, you can consider either this one, that is voltage controlled current source, or current controlled current source. So we will be, you consider this figure only, because you can write very easily. I mean, the explanation is very easy, so you can write it. So till here you can write for the hybrid pi model. Usually the explanation part they won't ask, but the hybrid pi model, that is this picture, particular picture, it will be asked. At that time you should write what is the amount of IB. I mean, in the picture you need to write on, this is base terminal, this is emitter terminal, and this is collector terminal, and what are the currents, and the arrow marks is very important, and voltage, it is polarity is very important. VBE, R pi, VB and VC are the independent sources, whereas IC and IB are the dependent sources. So it is output current, it is being mentioned like this. So what is IC? IC is equals to GM into VBE. What is IE? It is VB divided by RE. And the transconductance and R pi, it is the thing you have to write here. Okay, so this is what we can write from the write in the hybrid pi model. I hope it is understood. Okay, so the next is so the second figure, current control current source, it is an alternative circuit. So in the exam, either you can write voltage controlled or else current controlled. So this is the most widely used model for the BJT, that is hybrid pi model. So it is important to note that small signal equivalent circuits, like whatever we have seen, voltage control or current controlled hybrid pi model, the operation of BJT at a given bias point, that is at a fixed Q point, we can write this. So this should be obvious from the fact that model parameters, like what are the model parameters? As I told, it is GM, R pi and R naught. R naught, output resistance, it is not mentioned. So let us don't consider that. Model parameters GM, transconductance, and the input resistance with respect to base R pi depends upon the value of the DC bias current IC indicated in the figure. Okay, so this is what the explanation for hybrid pi model. So next is what are the recommended questions from these topics, like BJT biasing, that is two types of biasing we have seen, classical discrete circuit biasing technique and the emitter biasing technique. And after that we have studied the small signal model, and under that we have studied what and all we have studied. Small signal model we have studied, and what are the AC component, what are the DC component present in the BJT circuit, and what is the instantaneous voltages and current present in the circuit, and then how to obtain the emitter current and the input resistance with respect to emitter, collector current and the transconductance GM, and then base current and the input resistance with respect to base, and then we have calculated the voltage gain. And after that we have gone through a topic, small topic separating DC and AC quantities. Then we have studied about the hybrid pi model. So these are the things we have included under BJT biasing chapter. And today we are going to, now we are going to see the recommended question from these topics. So the first question is, explain the design constraint of classical discrete circuit biasing arrangement with circuit and relevant equations you need to write, and you need to explain how does RE provide a negative feedback action to stabilize the bias current. So let us see this, what and all you need to write down for this question. It has been asked for the 8 marks, very important question, one of the expected question in the exam. So the thing is, you need to draw these two figures, and you need to obtain, see in the figure, while writing the figure, drawing the figure, you have to mention all the component parameters, that is resistor values, current, voltage, all the things you need to mention in the figure. So in that time only you will be getting the full marks, otherwise you won't get the full marks. Okay, then the equivalent, Thevenin's equivalent, RTH and VTH value, or VBB or RB value, and then applying KVL for the input loop, obtaining equation for IB and then IE, and then you need to write down the KVL equation for the output loop. That time we'll be getting VC is equals to VCC minus IC into RC plus RE, and then you have to write down these two constraints. Why these two constraints are defined is, that is, you have to make your IE, emitter current, it is insensitive to temperature variations and the beta variations. So how these two constraints we are going to achieve, that has been explained over here. Some trade-off it has been made. So what is the trade-off? This is the trade-off that you have to write. That is, you have to consider the bias voltage as VCC by 3, and then VC or VCB as VCC by 3. Again, the voltage across the RC, it is VCC by 3. This trade-off solution you have to write down. And then the second constraint, that is RE should be greater than RB divided by 1 plus beta. Why that should be done? In order to satisfy that, This is the particular condition, that is typically one selects the R1 and R2, that is a potential divider circuit, such that their current is in the range of this, that is IE to 0.1 IE. So two designs are there. First design is by considering 0.1 IE, and the second design it is considering the voltage divider current as IE. Okay, so this is you need to explain and why the feedback resistor it has been included. It is covered in this particular explanation. You can go through. Okay, these things you need to write down. So next thing, what is the next question it has been asked? Okay, next question asked is this one. Considering the conceptual circuit of common emitter configuration, derive the expression for GM R by RE, draw the hybrid pi model of the transistor. That is, you need to derive the equation for GM, transconductance, input resistance with respect to base and with respect to emitter. You need to consider the conceptual circuit of common emitter. So, conceptual circuit of common emitter means this circuit you are going to draw. See, this circuit you are going to draw. Conceptual circuit. See, this is a picture you are going to draw. That is this one. You have to consider both AC as well as DC figure. That is a conceptual amplifier circuit. Okay. So simply if they ask common emitter amplifier, then you can write the only considering this VB, because VB and the base voltages, I mean the bias voltages VB and VCC, it will be considered as a short circuit for the general amplifier circuit. But if they ask conceptual, you have to write on both AC. You have to mention AC as well as the DC voltages applied. Okay, so this figure you need to draw, and then you need to obtain the expression for GM. By that time you have to write these four equations and then these equations. So this is the equation for the collector current, and then from the collector current equation you will be getting the transconductance equation, and from that you are going to calculate the input resistance. Input resistance R by VT by IP, and then this one RE is equals to VT by IE. Okay. Next is you are going to calculate the relationship. I think it has been asked in the next one. So for the second question, this much you need to write down, and for the last question here, draw the hybrid pi model. After that, you need to draw that hybrid pi model. It is this figure. This figure you need to draw voltage controlled current source. Next is one problem it has been asked, that is VGT having beta is equals to 120 is biased at a DC collector current of 1 milliampere. Find the value of GM, RE, R pi. Of course, you will be knowing the equation for GM, RE and R pi with the given information, that is GM is equals to IC by VT. IC is given 1 milliampere divided by VT is 26 millivolt. If you calculate, you will be getting the transconductance. Then RE, you know it is VT divided by IE, and then R pi is VT divided by IB. Easily you can calculate. IB you can calculate, that is by beta is equals to IC by IB. So IB is IC by beta. By like that you can calculate R pi. Next thing is the second model question paper. They have asked about derive the relation with respect to small signal operation. That is, you need to derive the equation for transconductance GM and the voltage gain. Voltage gain is VCE, output voltage divided by the input voltage, VC divided by VBE. And then the same question, same problem it has been asked here, calculating GM, RE and R pi. And the next question is derive the following relations with respect to small signal operation of VGT, that is the input resistance. Obtaining equation for R pi and the input resistance R pi, RE and emitter resistance. Emitter resistance means RE. Input resistance, if they ask, it derive the relation between these two, emitter and the base resistance. Base and the input resistance means it is what is it? Base and input resistance means it is same R pi. Okay. So these are the following important questions we have discussed. I hope it will be useful for you. Thank you.